Hi class, this is Neil and this is the second video in lesson 9. In this portion of the lesson, we're going to look at where sine and cosine waves come from. So this is the portion on the sheet, on the worksheet that you'll see. What I'm going to do is transfer though to the slideshow, which has a little bit more information. All right, so the question really is, how do circles become waves? So what you'll notice in this diagram is the dot that you see here is tracking with a position on the circle. So when we're creating sine and cosine waves, we're really just graphing the height of a position on a unit circle. So sine cosine waves, where might you have seen these? Well, we see them in ocean waves. If you've ever seen a diagram of a music wave or a sound wave, those are applications of sine and cosine. Light waves, when you study physics, you'll learn a lot about light waves. And weather, we see weather in sine and cosine waves. And that's kind of what you see in this diagram below. There's a temperature graphed over the course of a year, and you'll notice the temperature kind of goes up and down, and that process would repeat as we move into another year. And that's what happens with sine and cosine waves. Okay, so if we took the unit circle, and remember, a unit circle is just a circle with a radius of 1. So that's why you see those 4 points plotted along the x and the y-axis. So that's my unit circle there. And then around that unit circle, I'm going to put those quadrantial angles. So that's 0 through 360. Now, if I were to convert each of those angles to radians, these are the radians that I would have. Well, 0 degrees is the same thing as 0 radians. If I convert 90 degrees, which I think you did in the previous lesson, that's the same as pi over 2 radians. 180 degrees we talked about is the same as pi radians. 270 degrees is the same as 3 pi over 2 radians. And 360 degrees, like we mentioned in the do now, is the same as 2 pi radians. So that's the unit circle for us in radians. Now, this kind of is a transition into talking about where sine and cosine waves come from. So this is our right triangle in the unit circle. We've seen a lot of this before in previous lessons in this unit. We know the radius of that circle is 1, and that's what we see here. We also know that the opposite side is the same as the y value. The adjacent side is the same as the x value. If we have a point x comma y, then we know that the adjacent side of the triangle, again, is the same as the x value. The opposite side of that right triangle is the same as the y value. Now, to find y, this is really just a review. Whenever we're asked to find a y value, what we did is we made a sine equation. So we wrote sine of theta equals the opposite over the hypotenuse. In this particular triangle, we know that the opposite side is the same as y, and the hypotenuse is the same as 1. So that's my equation. Now, if I simplify that equation, I'll see that y is equal to sine of theta. So all I did really right there is simplify that equation. Now let's say you wanted to find, instead of the y value, you wanted to find the x value. Well, if that's the case, the equation that we would come up with is x equals cosine of theta. Now, all this is really just to get us to a point where we can see that in our unit circle, the x value is always the same as cosine, and the y value is always the same as sine. So this is super important when we get into talking about these waves. So remember, our x value is always cosine, our y value is always sine. All right, so what I've done here now is taken my unit circle. You'll notice I have here my points, 1 and 0, 0 and 1, negative 1 and 0. I have my radians here, 0, pi over 2, pi, 3 pi over 2. And then I have, just as a reminder, cosine is always my x value, sine is always my y value. And I have that underneath each of the points in my circle. Now you'll notice here in this coordinate plane that the x values in my coordinate plane here, I've got pi over 2, I've got pi, 3 pi over 2, and 2 pi. These are my angles. These are the angles that appear around the circle. So to create a sine wave, what I'm actually going to do is track the position around the circle as we move from quadrant to quadrant. Now we don't necessarily need to see that quadrant 1, quadrant 2, quadrant 3, quadrant 4, but that's just so you can see that what's happening in the wave is I'm really moving around the circle and tracing where the y values go. Okay, so if I'm at 0, my y value is 0. If I'm at pi over 2, my y value is 1. So that's why you see this point of 1 over pi over 2. If I'm at pi, my y value is 0. And that's what you see on the coordinate plane here. If I'm at 3 pi over 2, my y value is negative 1. Okay, so what we've actually done here, and if I'm at 2 pi, which I kind of skipped over, 2 pi is the same as 360, so I'm back at 0. So what we've really done here is we've moved around the circle. And in the process of doing that, we've created a sine wave. And this wave really just continues in both directions. So if I wanted to continue it in the positive direction, I just draw a little arrow there. If I wanted to continue it in the negative direction, I draw an arrow in that direction. But notice it never goes beyond 1 and negative 1, because that's what I see in my unit circle. Okay, so that's a sine wave. For a cosine wave, we're going to be tracing where the x values go. So what happens to the x values in my unit circle as I go from 0 all the way around to 2 pi? So at 0, the x value is 1. So I'm going to plot 1 in my coordinate plane. At pi over 2, my x value is 0. So that becomes my y value in my coordinate plane. At pi, the x value is negative 1. At 3 pi over 2, the x value is 0. And at 2 pi, the x value is 1. So again, all I've done is I've traced what is happening to my x values as I go from 0 to 2 pi. Okay, so that's a cosine wave. All right, now, again, that wave continues just like the sine wave. Notice the pattern really just repeats itself. Okay, so here's two other graphs of sine and cosine. What's the big difference that you notice? Well, what you should see is there's a negative value in the front of the sine. There's a negative value in the front of the cosine. So when I create these two other graphs of sine and cosine, what I'm going to do is really just flip the value from positive to negative or vice versa. So for sine, if I start at 0. Notice the next value in the sine graph was 1. In negative sine, it's going to be -1. The 0 value doesn't change. At 3 pi over 2, notice it was -1. So, excuse me. At 3 pi over 2, it should be +1. And then we go back to 0. All right, so there's my negative sine graph. Of course, I could extend it in this direction. For my negative cosine graph, again, I'm just going to flip where those values are. So we would have started at 1 on the y-axis. For negative cosine, we start at -1. And again, the values just flip. So at pi, where we would have been at -1 in cosine, we're at +1. So here's my kind of rough sketch of negative cosine. All right, so that's going to be the end of this video, and we're going to look at how you would use this information to do the problems in this day's lesson.